My name's Johnny. I'm an engineer on the Firebase team. And today I'll be telling you how you can use Firebase to create a robust and scalable backend. So Doug just gave a great overview over Firebase and the ever-growing suite of products and how you can use them to build or extend the functionality of your app. And now I'll be digging into one particular product that I'm very excited about. Before we do that, let's look at some of the use cases that you may have in mobile apps. One of them may be you want to send a notification whenever a new message arrives in your app. Maybe you want to resize images or create thumbnails whenever a user uploads a new photo. You may want to add some filtering for messages. Maybe you want to add or provide some discounts for inactive users or even reward the most active users. And as your app grows, you maybe also want to add third-party integrations and you want to provide some API endpoints. And to do that, you need to run some code somewhere. And traditionally, you have a backend somewhere, some servers that you need to provision and run and manage where this code lives. Let's dig into one of the examples, resizing an image after photo upload. So the way you do this traditionally is you have a custom backend, and your app talks to the custom backend. And the user uploads the photos, you run some code, you resize the image, and you store it in storage. And so writing the code to resize the image is actually really simple to do. In most environments, you have some library, and it becomes as simple as including that library and calling a single line of code. So that's the easy part. But once you go down that route, you can no longer use the Firebase SDKs as easily anymore, and you lose a lot of the benefits that they provide. You may want resumable uploads and resumable downloads, and now you have to build that functionality yourself. You don't get it just through using the Firebase SDKs. You'll have to provide some kind of authentication, and you have to make sure that the uploads are authenticated, so only users that have access can actually do that. And then you have to deploy your servers, and you have to make sure that they are provisioned to handle the load of your app. And when your app doesn't have that load, you still have to pay for those servers. So you don't get pay as you go. And you don't get global scale. You sort of start out with some servers. As your app grows, you need more servers, and now it becomes a whole operation. A while back, we announced Cloud Functions for Firebase. And it's in public beta, and it's being used. And this product allows you to write code that runs without managing your own servers. And we have a tight integration with all of the Firebase products. And we provide an SDK that makes it really easy to manage your functions and makes the integration really seamless. So let's go back and look how Cloud Functions can help here. You still have to write the code to create the thumbnail, but that was the easy part. Cloud Function takes care of the rest, and you get to use the Firebase SDKs and use all of the awesome features. And it doesn't only work for resizing images, it works for all of the use cases we just looked at too. The way to think about Cloud Functions is kind of as glue code. So as you use Firebase products or Cloud products, or maybe even your own APIs, you can use Cloud Functions to sort of customize the way they interact and combine them into an awesome app. Firebase comes with an SDK that you can use to debug and maintain your functions. And I'll show you later how that works. So how does functions work? Basically, you tie a function to an event. Functions is event-based. That means that whenever an event is emitted, functions will look up which function to run and run that code for you. And it will automatically spin up an instance execute your code, and once it's done, it will spin down the instance again. So how are events emitted? They're emitted by event providers. That may be cloud storage, for example. Whenever you upload a photo, it will emit an event that says the photo is uploaded, and you can run a function then. But further, you can also specify under which conditions a function should run. For example, in storage, it should only run when a photo is uploaded to a particular bucket. So let's look at the resizing example again. You can use the Firebase Storage SDK to upload to storage directly from your app. So we have that done. Once the photo is uploaded, you can trigger a function and resize the image, storing it in a new URL. And you can then write that URL to the database. The app can then listen to that URL in the database, and then it will get the notification in real time, and you can, in your app, you can now display the resized image. One of my favorite kinds of events or triggers is the HTTPS trigger. You can think of it as a web server on demand. So let's look at some code and see how that works. Here we have one of the simplest possible functions you can write. It's kind of a hello world of functions. Let's walk through the code. The first step is to include the functions SDK. We're writing in Node. Functions runs Node.js code. So if you're familiar with Node, this is just a normal Node module that you can include. Next, we'll have to tell Cloud Functions what function we actually have. And the way to do that is using modules and exports. So this is a standard Node paradigm where traditionally all of your code is private, but you use the exports global object to define what your module exports. And this is the same mechanism that Cloud Function uses. So here we define a function called hello world. Next, we use the functions SDK to determine what kind of event we want to listen to. In this case, it's an HTTPS trigger. And we call onRequest, and now we can provide it with a function body. And this will be called whenever someone browses the URL that is exported by functions. Cloud Functions will invoke this URL. We pass it in a function that is called, and HTTPS triggers uses the popular Express.js framework. So the objects that get passed in are just normal request and response objects that you might be familiar with from Express.js. We'll go ahead and ignore the request, but we'll use the response object to send out a hello world. And now we're done. And with that, we have a scalable web server sending hello world. After writing the function, the next thing you want to do is actually test that it works. And for this, you can use the Firebase CLI to serve it locally. The Firebase serve command is useful for a couple of products. So if you're only testing functions, you can specify -- only functions, and it will only serve the functions portion. If you're using hosting, for example, you can also specify hosting, and it will serve both products at the same time. Once you call that function, the SDK will automatically detect which functions exist, in this case, hello world, and it will provide a local URL that you can browse to actually execute your code. Once you've verified that it behaves like you actually want it to, you can go and call Firebase deploy. This will actually go ahead and deploy your function to the cloud. It will do a whole bunch of stuff in the background, so this may take a couple of minutes, but it'll tell you on the way what it does, and eventually it will tell you the deploy is complete, and will give you a URL in the wild that you can now browse to from any web browser or using curl. And with that, we have a scalable web server in just a few lines of code. Let's go ahead and look at this live. I'll ask Doug to help me out because typing and holding the microphone is pretty difficult.
It's a skill that everyone has to learn at some point.
So we have an index.js with the same code from the slides. Let's go ahead and serve this locally. So we'll use the Firebase serve command. It will go ahead, it will load up the functions, it will see what functions were defined. And then it found the hello world function, and it gives us a local URL. So let's go ahead and browse to that URL. And there we have hello world. So let's go back and actually make it do something useful. Let's say we're going to create a new software as a service that allows you to convert text into uppercase, something that we get requests for all the time. So we'll rename the function to upperify, and then we'll actually use the incoming request to determine the string that the user wants to convert to uppercase. We'll convert that to uppercase, and now we'll respond with that text. Because we're an API, we probably want to respond with JSON. So I hope I don't have any typos. We wrote the function. Let's go ahead and try out that. It'll go ahead and look for the function again, and it'll give us the new URL. It responded with a JSON, but we didn't provide the text yet, so let's try that. So we passed in the text, and it converted it to uppercase. So now we have a software as a service in 4 lines of code. We verified that it worked correctly, so let's go ahead and deploy that function. It'll go through the same steps, detecting what functions exist, and upload that to the cloud. I see a question.
Would this pick up local changes automatically, or do you need to restart the Firebase serve then, whenever you change the function?
That's a good question, Doug.
Yeah, actually, it will detect source code changes and reload the function. So you have like inline. You have the ability to make inline changes without having to shut down and restart.
All right. So it's currently deploying, and it'll take a while until it's set up everything correctly. Let's just give it a minute.
It's always just giving it a minute with the deploy. The team is actively working on improving the deploy times. When the product first launched, it was actually, I'm going to say, fairly miserable to deploy, and it's gotten better. Have you deployed to this project before?
I have.
Okay.
Okay, there we go. So it gave us a world-readable URL. Let's go ahead. And now our API is live. So that was HTTPS triggers. A few weeks ago, we launched Cloud Firestore, and Doug talked a bit about what it can do. One thing that was clear to us is Cloud Functions was very popular with the real-time database. So we made it a priority to launch with functions integration on day 1. And so Cloud Firestore can be used to trigger Cloud Functions. Let's look at another example. Let's say you're building a chat app and you're storing your messages in Firestore, but you want to add support for push notifications. You have a chat app with multiple rooms, and you want to notify all users in a room whenever a new message arrives. And we can do that in just a few lines of code. Let's walk through this example. Again, we'll have to include the functions SDK. And you may notice a pattern here. The functions SDK provides a bunch of different event kinds and event triggers, and it's all exported on the module. So in this case, we're interested in a Firestore event. We'll specify a document path, meaning that we'll only actually execute this function if a document is written to that particular path. But we can provide wildcards to make sure that we don't depend on specific document IDs. In this case, whenever a document is written to the path of rooms/room ID/messages/ID will get executed. And then finally, there's different event types in Firestore. For example, you can only run a function if a document is deleted or updated. In this case, we only want to send a push notification when a new message arrives, so we call onCreate. This will only be called when a new document is written to that path. We'll give it the function we actually want to execute. I see a question.
How do you connect these functions to your project? You have to like set a config in the CLI, or you have to have some config file?
That's a good question. So in the code itself, functions will automatically detect the project. But when setting up the Firebase CLI, you can specify which project you want to deploy to. So we'll pass in the function, and we get an event parameter passed in. This is a very typical pattern for cloud functions. The event parameter exposes all of the metadata that is associated with this kind of function. In the case of Firestore, it will actually provide you with the data that was just written to the document. It's very similar to how it works in the client SDKs. So we can use that event data to get the fields that were written in the message. Next, we'll use that to create the push notification by extracting the username and the text. And once we have the notification, we can now send it. For that, we'll include the Firebase admin SDK. The admin SDK is the Firebase SDK that lets you do stuff that is typically done on trusted backends, not end-user devices. A good example of this is sending push notifications. You don't want your users, unauthenticated users, to be able to just send push notifications on your behalf. You want to do that in a trusted environment, and the admin SDK makes that really easy. You'll have to make sure to initialize the admin SDK, and for that you call initialize app. Normally you specify a service account with credentials, but we all know that checking in credentials in source code is never a good idea, and actually very dangerous. And so functions actually makes this really easy. You can call functions.config.firebase, and it will automatically set up the right credentials for you. And this will work not only while running in production, it will also do that when running locally with the Firebase SDK. So we have the admin SDK initialized. Now we can go ahead and actually send the push notification. For that, we call admin messaging, which gives us access to the messaging SDK, and we call send to topic. And as you noticed, we only want to send the notification to the users in the room, and we use FCM's topic mechanism for that. And the ID we use is just the room ID, and we can use the wildcard that we specified earlier. That will be populated by functions and exposed in the params object on the event object, and we'll pass it in the notification. Cloud functions are asynchronous. That is important because a lot of work that you do in JavaScript is asynchronous, and functions needs to know when your function actually can be spun down. And the way to do that is to return a promise that is done once all of your work has finished. You can return any promise, but since send to topic already returns a promise, we can just do that here. And with just these few lines of code, we can now send push notifications from our app. The Firebase SDK comes with a cool feature, a cool experimental feature, a shell that lets you interactively call your functions. Because it's experimental, it's hidden behind the experimental flag on the command line. But calling this will go ahead and load up your function in the shell. And now you can run normal JavaScript and pass in the parameters that you want to test. If you're using wildcards, you can also make sure to pass in the correct wildcards, so you also have that portion covered. And again, once you're done and happy with your function, you can call Firebase deploy, and it will now start to be live. So let's switch back to the demo. Okay, so here we have a slightly modified version of the push notification code loaded up. Instead of sending push notifications, we will be replacing certain words with emojis. We have the emojis defined here. We have a small helper function to actually do the replacement. And then we have the emojify exported function that looks fairly similar to the push notification function from earlier. Let's go ahead and comment out this line so we don't actually write any data. And we can go and load it up in the shell then to see what it does. So it found the function, and now we can call emojify with the data we want to test. It invoked the function. We logged the incoming text. We logged the modified text, and it seems like it's working just fine. So let's go ahead and deploy that. We'll go ahead and add back the line that actually writes the data back to the database. We call data.ref.update for that. Data.ref is the reference to the document that was passed in initially for this event, and .update just updates the field. So in this case, we're just replacing the text with the new text that we just generated. We'll call Firebase deploy, and it'll take a while again. So let's just wait until that happens. By the way, the SDK will also make sure that everything works, even if you're using it for this first time. So we'll go ahead and check that all the necessary APIs are enabled and make sure that everything's running correctly and tell you if something may be wrong and how to fix it.
Eventually, the team wants to have like comprehensive lints in there. So the idea is to look at your JavaScript code, especially the code that deals with promises, because those are easy to get wrong, and sort of give you some assistance in helping point out what could be going wrong in your project before you actually run it. So I'm kind of excited about that, because we get a lot of support requests from people who aren't dealing with promises correctly. And it's especially like, I'm not, you know, I do Android. I'm not do a lot of JavaScript, so promises are kind of a foreign concept.
Cool. So the function was deployed, and now we'll use a very intuitive chat UI called the Firestore console. This is the console where you can see all of the data that is stored in your Firestore database. But you can also use it to add or modify data, and anything you write here will also execute the function. So let's go ahead and add a new chat message. We'll assign it just a random ID. We'll invent a username for now, and we'll add some text. We'll save that message. It will open up the document, and you can see the text here. And it will go ahead and spawn the function, and eventually it will write back the data. Voila. So often you have your app deployed and you want to change your behavior without actually having to redeploy your app, and function makes that easy too. We can go ahead and add new emojis. I'll ask Doug to help out again. So luckily, I don't know how to type emojis, but I was smart enough to add the LOL emoji in the comments, so I can just copy and paste that. We'll add the LOL emoji. So, and we'll redeploy the function. And while that happens, we can now, without actually changing our app, in this case the Firestore UI, which is really difficult for me to change in this instant, we'll get the new functionality once the function finished deploying. So it's updating the function right now. And we'll wait a bit longer. This is a known pain point, as Doug mentioned. Okay, so the new function is live with the new emoji. Let's add a new chat message. We'll assign a user ID again. We'll invent a username. And we'll save that new message. It'll go ahead and run the function again. It's always a bit slower the first time you deploy a function, but there it goes. We now have new functionality without redeploying our great chat UI. So, you can just write the code that you want to write, and Cloud Functions will take care of the rest and make sure that it scales up automatically, and you only pay for the invocations that you actually use. And this is really good, because as you're developing your app, you don't really run the code that often. It just runs occasionally. But as the app scales up and you get more usage, you only pay for what actual usage you use. You don't have to over-provision. So we talked a bit about the kind of triggers that exist. We talked about HTTPS endpoints. I showed you Cloud Firestore. The same triggers also, or the same events also exist for the Firebase real-time database. But there are a bunch of other products as well that work with functions today. For example, Cloud PubSub, Firebase authentication, Cloud storage for Firebase, Google Analytics for Firebase, Firebase hosting, and more. And all of these products can trigger Cloud Functions, and you can use it to sort of glue your, or you can use it to extend the functionality of all of these products while still getting all of the awesomeness that they provide. If you're interested in more integrations, make sure to sign up for our alpha program. We also have a bunch of examples in our GitHub repository. So if you want to know how to build more complex example with functions, make sure to go and check them out. And then if you're interested in learning more about Cloud Functions, we have a code lab that takes you through Cloud Functions step by step, making sure that making sure that you understand each step and how to get started with Cloud Functions easily. So that was Cloud Functions for Firebase. Thank you. And are there any questions about Cloud Functions?
Are the functions available during deployment? So if you are like deploying a new version of your functions, can you still reach the server?
Yeah, so the way deployment works is it's staged into an area that doesn't replace your existing function. So theoretically, you should have no downtime during a deployment. So there should be like kind of an atomic switchover point. At least that's the way it's intended to work.
That's nice.
Yeah.
One. You showcased the usage of Cloud Functions as a database middleware. And is it technically possible for the Cloud Function itself to connect to the database, I mean to the database contents?
Yes. So in a Cloud Function, you can basically run any kind of node code that you could typically run on your own server. So you can just read and write from the database. You can make calls to other services as well. You can make web requests. Anything you could typically do in a node program, you can also do in functions.
Okay.
I'll add one thing to that. Cloud Functions is available on the free tier, so if you create a project and it's on the Spark plan, which doesn't require a credit card or anything, you can work with Cloud Functions, but one limitation is that you can't make outgoing socket connections to non-Google services. So, but keep that in mind if you're doing a hackathon. If you do need to connect to a non-Google service, you will need a credit card, and the cost will be minimal, but you can do that. And one other thing is it's very common, that is a very common use case for someone to want to mirror what's in their Firestore real-time database with another database provider. So one thing that real-time database and Firestore don't do is full-text search, but there are other great full-text search providers out there. So one thing you can do is trigger a Cloud Function to run when data changes, then write that out to the external provider. Now you have two places to query for your data, one for NoSQL type lookups, and another for like full-text search lookups.
When you deploy, will Firebase upload the local node modules folder, or will it install on the server?
That's a good question. I think that it does an npm install on the server. So I don't think it uploads node modules directly. So when you saw the deploy happening, like the total package was something like 60K, which is there's no way that is the entire contents of, yeah, so it's like 60 kilobytes. So it's not doing the entire node modules folder. I think npm is managing it on the back end. So if you cat project, or what is it? What's the name of the node package.json? Yeah. So yeah, so all of the service, all of the versions of everything are pinned. So when you do npm install locally, you're getting everything and sticking it in node modules. Then when you deploy, it's basically reconstructing all of the modules you're using.
Which node version are you using?
Right now, Cloud Functions runs, so it's always going to run an LTS version. So the current version is 6.11.5, I think. And I know that everyone wants node 8, so then you can do async await. That's something that we want to do. I can't give you any timelines for that, but yeah, LTS version. So we had a question here.
Don't worry. The Cloud Function question is the programming language is just Node, or do it support another languages like OpenWhisk or something like that?
Yeah, so right now everything is Node.js. We have a lot of people who are interested in Java, Python, Go. We don't offer those right now, but the team is busy trying to make those things happen. It just turns out, incidentally, each language in runtime has its own individual technical challenges that need to be solved. So if it was easy to spin up Java, which I would love because I've been doing Java and Kotlin since forever, but yeah, we're going to have to wait for that, unfortunately.
Thank you for the talk. Quick question, so regarding the Cloud Functions, is there any mechanism to run the Cloud Function on schedule? So without using any external servers, services, and so on?
Yeah, that is like the #1 FAQ. Unfortunately, you have to bring your own scheduler right now. Abe Haskins, one of our coworkers, wrote a blog about that. We also have a video on YouTube by Jen Person that talks about using cronjob.org to ping an HTTPS function. So you have to bring your own scheduler. Okay. That is something that I think we would save the world if we could do scheduling of cloud functions, both scheduled on schedule and on delay. I want to see both of those personally. Okay. I have feedback in, and
is it on the roadmap already, or
we're working really hard on it. I can't tell you when that's going to happen, though.
I see. Thank you.
You said that it's not really a good idea to store credentials, for example, in your source code. And the question is, where can I store them? So, for example, can I create environment variables or something like that?
You can. That is exactly what you can do. So the Firebase CLI has a way to associate key value pairs. And when you deploy, those key value pairs will go up with it. So, and I've done this where maybe you have a service account. You need to use a service account, but you don't want to put that service account file in your functions folder and deploy it. What you can do is stick that into an environment variable, and then there's an API to read that out. It's pretty straightforward.
Thank you.
Thank you.
Thank you all.